jump right in. So calculating curvature, we need two things. We're going to need R prime. And R double prime. Now we calculate the cross product. Eight t squared minus 4t squared. Negative quantity of 4t minus 0. And then 2 minus 0. And factor out of 2. Which is going to make finding its magnitude easier. Absolute value of the scalar times the square root now of the sum of the squares. 4t to the fourth plus 4t squared plus 9. And that can be simplified. That's a perfect square binomial. So this is what we get for our magnitude. Why no absolute value?
Is that the square root thing, the magnitude of the 2t squared stuff?
Yeah.
Okay.
Why no absolute value? Remember, when you take the square root of an unknown, it's supposed to be an absolute value.
Because the item is getting squared.
Well, so is x squared. But the square root of x squared is absolute value of x. So why is this not around absolute values? 2t squared plus 1, is that ever negative? That's why you don't need absolute values. Right? If that was, for instance, 2t plus 1, you would need the absolute values. Right? Because that could then be negative. One more thing, we need the magnitude of r prime. Well, look at the components of r prime versus r double prime. With the exception of order and sign, they're identical, aren't they? After you factor out the two. Not r double prime, sorry. R prime cross r double prime. They're identical. Which means the magnitude is going to be the same. Let's see how we can draw a kappa. Yeah, good enough. Curvature represented by the lowercase Greek letter kappa. When it's given, when the curve is given in parametric form, was derived to be magnitude of r prime cross r double prime over magnitude of r prime cubed. That would be your curvature as a function of t. Which means your curvature is not constant, right? The curvature depends on where on the curve you're located. T, N, and B. Unit tangent, unit normal, binormal. Now the unit tangent was already discussed. That was discussed, what was it, last Thursday? Need r prime, then you're going to need the magnitude of r prime. Because we want to normalize r prime. It shouldn't be difficult to see. You'll get the square root of 9 plus 16. Which is 5. Then you get a 9 sine squared plus 9 cosine squared. there's t. There's our unit tangent. This will round up being nice in the sense that the magnitude of r prime was a constant. That is generally not the case. The magnitude of r prime is not constant. That generally makes finding now the normal more difficult. Because I'm just not seeing this. The unit normal vector is tangent to the unit tangent. So the normal vector is tangent to the tangent, which means we need to take the derivative of t and then find its length so we can normalize it. Thankfully, this one is easy. Shouldn't be difficult to see what that length is. It's just 3/5. Normal vector. 1 over the length of t prime times t prime. And there's the normal vector. Your binormal vector is the vector tangent to both of those. We define it to be t cross n. This one might take some work. Bless you. No, that's nice. 0 minus negative 3/5 cosine t sine t. No, that's not right. Did the wrong order. Negative 4/5. That'd be 0 minus negative 4/5 sine of t. And so 4/5 sine of t. Next one, 0 minus negative 4/5 cosine t, and then the negative of that. Those two components were fairly simple. Now we get 3/5 sine squared minus negative 3/5 cosine squared. Oh, that one was nice. Didn't require as much as I thought it was going to. That would be our binomial vector. So length of the curve. We're going to be integrating the length of r prime. So let's go ahead and find the length of r prime. R prime. Oh, this is a nice one. Five, 4, 1. Then it's length square root of 25 plus 16 plus 1, which is what? Root 42? Two times 3 times 7. Bummer. Can't be simplified. All right, so all the texts use S for the arc length, little s, right? I don't know, I like L to represent length. Doesn't matter. Integrate over the interval. Length of r prime dt. There's a nice little shortcut. If you integrate from A to B of just a length differential, it's just the length of that interval, B minus A. Seen another way, integrate over an interval of just the length differential, is just the length of that interval. So if you're integrating just a constant, wouldn't it just be the constant times the length? What's the length of our interval? It's just 1, isn't it? That integral is just root 42. I will be using that quite a bit. Guess this one. Save the best for last. Compute the length function of this curve. First, we need R prime. That's a product rule, isn't it? Derivative of the scalar times the vector plus scalar times derivative of the vector. E to the negative 5t common, so factor it out and combine the two vectors. Length of r prime. Absolute value of the scalar times the length of the vector. Oh, this is going to be fun. E to the negative 5t. What do we know about the range? So what's the range of e to the negative 5t? Positive, right? We don't need the absolute values. Square root. Okay. Now I have to expand out those two terms. There's your first term expanded. There's your second term expanded. Those two terms, they sum up to what, 25? Those two terms in the blue, that's just 0, right? Okay, that's nice. What about those two terms in the green? 4. 25 plus 4 plus 25. 54. Square root of 54. It's 3 root 6. Another actually, can't forget that e to the negative 5t. We want the length function. Now I will use little s. So how do I want to do this? I'll do it this way. I'm going to integrate from a to t because they didn't tell us a starting point for the curve, right? They didn't give us like t is 0 to something. So I'm just going to choose an arbitrary starting point a. And we integrate to t. Magnitude of r prime of u du. Antiderivative of e to the minus 5u is what? There's a negative out in front. So you could do it the way that you're doing it, but then your front term be negative. So I just flipped the order.
Never mind.
And we'll factor out that 3 root 6 over 5. So write it this way. And say there's our function. Domain for t be from a to infinity. Right? Again, because they didn't give us an actual interval to consider.
We always have to provide an interval when you answer this question. Like if it's not.
If an interval is already provided, no. Right, so if instead I said, compute the length function over the interval 0 to 8, then no, it'd be implied that's the same interval. Because there wasn't one given, you do have to restrict it. Right, because you can't have t being less than a in this case. Because that wouldn't make sense since I'm starting at a. Now, it didn't ask for it. But what if it wanted the arc length parameter? Or the arc length parameterization? Right. Well, the arc length parameter is S. Which means you'd have to solve that for t. This one actually isn't bad to do. So we already had this, right? S is do I want to keep it this way, or do I want to use the factored form? I don't know. I will use the factored form, I think. I'll write it this way. Right, we have to solve for t. Well, the first thing to do would just be to get that 3 root 6 over 5 to the other side. Remember, a is just some constant. So move that e to the negative 5a to the other side. Get rid of the negative. Now what?
Can you take the natural log of both sides?
There's your t in terms of s. What you would then have to do to get your arc length parameterization, which is r of s, take what we just found for t, go back to the parameterization. Everywhere there's a t, you put that in. And that would be your arc length parameterization. Yeah, it looks hideous, doesn't it? It is hideous. And then, of course, you have to determine now what's the integral for s, which I'm not going to worry about because that's too hideous. I don't feel like doing it. But that is how you would find an arc length parameterization. And if you remember, if you looked at the slide, that's the definition of curvature. Right? It uses r, I think it's r prime of s it uses, or t of s, something like that. It's the length of t of s, isn't it? If I remember correctly. It's the actual definition of curvature. Length of dt ds, even worse. So using the definition of curvature, this is the first step. Then you have to take its derivative with respect to s. Normalize that. That gives you t. Then take that derivative with respect to s. I'll let you do that for this one. Have fun. It'll make you appreciate that formula much more. Questions on arc length and curvature. Let me give you another one for that's back there. I'm not here on Tuesday. I'm going to have a little bit of time to fill that out for the linear exam today. So on this sheet, you can write anything you want on it, double-sided. The only restriction you have is it has to be handwritten. Otherwise, anything's fair game. You'll be allowed to use this sheet on the exam, along with, if you print out the tables that I posted, those are also allowed. You'll then turn this in with the exam tomorrow. For the exam, make sure you bring pencil or black ink pen. That's all I will accept. Also, bring your calculator. If you forget it, you can't use mine. And make sure your calculator's charged. Again, if it's not charged, you can't do the line. So that would really suck. Exam does cover everything we've done up through and including today. You have the entire 75 minutes tomorrow to take the exam. We'll start at 9:30. If you're late, you don't get extra time. It's 50 points. Should be more than enough time to complete it in 75 minutes. Hate these 3-day-a-week courses. Never give you enough time to actually do the exam. Otherwise, you have 2 homeworks. One is due tomorrow. Okay.
Are we gonna have like a review or something?
I don't typically do reviews. If I have free time at the end of the semester, I do an overall review, but otherwise, no. So just go over the notes, videos, practice problems, web assign. Generally, that's a good indication. Next homework due tomorrow, that is on the calculus of vectors. This homework will be due next Thursday. And continue working on your project that's due next week as well. Second project. Otherwise, I'll leave the rest of this time for you to get started on that reference sheet. See you tomorrow for the exam.